Gonna go ahead and get started. Wanted to remind everybody that, well, and I don't have everybody here yet, but hopefully they'll come in a little bit later and listen to the video, the first part, that we're not taking a final in first semester, not a cumulative final, but this Friday we have the non-calculator portion of the Chapter 3 test, and then the last day of the semester, which is Thursday the 28th, that's when we're going to take the calculator and formula portion of this test. So no, we don't have a final. It's not a cumulative final, but we do have a test on the last day of the semester. So just keep that in mind for any planning that you're doing. We just have a couple of chunks to our objectives here that we need to complete, and that's going to be calculate the future value of annuities. And annuities, really that language for many, many years was just used for situations where somebody won a large settlement in a lawsuit, and it might be an insurance case of one type or another. But annuities more and more are starting to describe any type of retirement funds that people have. So we want to figure out, find the monthly payment to accumulate a future value, how much money you want in the future. Find the term of the investment knowing the monthly payment and the future value, and then calculate the present value of loans and mortgages and determine the monthly payment knowing the present value. This is often something, this last one, that most people just turn over to the bank. When you close on a house, they just assume that everybody's done all of the math right and everything's working out. But it definitely is a good idea to understand the math that's taking place as you figure out what your payments should be. So we have the last 2 pages of the notes to talk about. And like I said, annuities. An annuity is a sequence of equal periodic payments. And like I said, it's usually you won a large settlement, or it always was in the past. You won a large settlement, and whatever business or insurance company it was said, we can't pay out $2 million right here today. We don't have it. If you want your money, you're going to have to take it in payments. And then they would schedule these payments. The annuity is ordinary if deposits are made at the end of each period at the same time the interest is posted in the account. Now that definitely makes the math easier, so that's the reason we're going to look at just the ordinary annuities. So only ordinary annuities will be considered in our textbook. We're not going to allow anybody to join in halfway through that compounding period. We're going to say, hey, you have to wait until the compounding period ends before you put more money in. So let's consider an example. Suppose Sarah makes $500 payments at the end of each quarter into a retirement account that pays 8% interest compounded quarterly. How much will be in Sarah's account at the end of the first year? And then we'll look at the pattern. So at the end of the first quarter, she has that $500 that she's put into the account. But at the end of the second quarter, she has earned some interest. So we try to figure out, well, if that's 100% plus 2%, where did the 2% come from? And we realize that it was 8% each quarter. So they're dividing up that interest rate to each one of those quarters. And then, of course, for the end of the third quarter, she has her original $500. She has the second $500 that she put in that earned some interest. She's got the third one now that's going to earn some interest. And actually, I said that backwards. This would have been the first one she put in, the second one she put in, and there's her new 500. And so that continues on. And you can see how that amount of money is growing, not just because of the interest, but also because she continues to put money into that account. And that's usually how it's done when you get, a job that gives you a 401k or something like that. They'll usually take money either monthly or at the end of the quarter out of your paycheck to put into those retirement accounts. Now, future value, this is what you'd want to know if you're making plans for your retirement. The total value of the investment returned from an annuity consisting of all the periodic payments together with all of the interest. So Sarah, let's just say she's young and she's got 35 years of working to do, and she's already started this retirement process. Maybe Sarah wants to see, if I keep doing this, how much money am I going to have at the end of 35 years of working? Well, that's the future value of this investment that you want to find. So down here, the future value of an annuity is found with this lovely little formula here. So the future value of, or FV, capital FV, of an annuity consisting of N equal periodic payments of R dollars at an interest rate I per compounding period, like it says, that's called a payment interval, is, and we take a look at this and we realize we've got that one new piece in here. And that's that little I. And they mentioned what I is. They said that I is the interest rate per compounding period. We'll just call that N. So you have your interest rate as a decimal, and then you divide that by N, or your book actually uses a K. Let's stick with K so we don't get those things confused. R over K, where K is the number of compounding periods. So in Sarah's example, 8% yearly, but 4 compounding periods came out to 2%. So that's where that new variable is coming from here. And we have this big R piece right here. And like it says, we've got N equal periodic payments of R dollars. So that would be Sarah's $500 that's going in there. And that's how we would calculate that future value. So calculating the value of an annuity is what we want to do. We want to use that formula and figure out, where do all these numbers go, and then how do I get this punched in so that I get the right answer. At the end of each quarter year, so every quarter, Emily makes a $500 payment into the Lanigan Mutual Fund. If her investments earn 7.88% annual interest compounded quarterly, what will be the value of Emily's annuity in 20 years? So here she's doing some planning. Emily is thinking ahead, and she wants to know, in the future, which would be the future value, what she's going to have. So her payments are $500. And now, if this is something you wanted to punch in all at one time, this is a really big mess to do that with, because we would need parentheses for this entire fraction, and then we'd need parentheses around the numerator in addition to the parentheses that they have there. And anytime we put a fraction in, we'd want parentheses. So this is another one where you're going to see me punch this in according to the order of operations so that I don't have to have quadruple parentheses anywhere in any of this. So there's the $500. Now, big parentheses. We've got 1 plus I. And I, again, is the interest rate divided by the number of times that that's going to be compounded. So 0.0788, moving our decimal 2 places. And they mentioned in here twice that this was going to be quarterly. We've got each quarter year and compounded quarterly. So 1 plus 0.0788 divided by 4. And then we have this N. Like I said, we have to be careful. They've used a lot of variables here. And N is the number of compounding periods. So what we have to do is figure out how many times this is going to happen and for how many years. Well, right here at the end it says 20 years, and like I said, they mentioned quarterly twice in this problem. So N in this case would be 80. So that's going to be our power up here. And then we have the -1, and that's all our numerator. So again, we're going to have to be really careful punching all of this mess in. And then on the bottom, we see that there's another I down there, so that's our 0.0788 divided by 4. So as I said, if you love lots of parentheses, You could try and punch this in all at one time, but I tend to do it in pieces and follow the order of operations. So I'll start with innermost parentheses, work my way out. I'll subtract 1. That will give me the numerator. And then I'll divide that by 0.0788 divided by 4. And finally, then I'll multiply the whole thing by 500. So let's see what we get. All right, so starting inside, we have the 0.0788 divided by 4. We need to add a 1 to that. And then that needs to be raised to the 80th power. Then we subtract 1. And that's all the math that takes place for the numerator. We've got all of that. So now we can divide that by the denominator. And yes, if you're thinking, hey, it's a fraction, we could multiply by the reciprocal, you're right, but why do all that thinking when we're punching this in anyway? So we've divided by that value for I, which was 0.0788 divided by 4. And now let's take that times that 500 payment. So notice, at no time did I stop and write any of this down. I didn't do any rounding all the way through it. Everything was kept track of by the calculator, all of the decimals and everything in there the whole time. So I really find with these, unless you end up with something beautiful that you can do the division for I, it really is a, hey, write down the formula and then punch it in correctly. And that really is how you show your work. If we had something that worked out really nice, like let's just say it was 8% 4 times a year, then yeah, simplify that to a 2, you know. Otherwise, hand it over to the calculator and just be very careful. So the future value, $95,483.39. So Emily's going to want to think about, what does she want to do after she retires? Right now, I know that they're recommending that most people have about $1 million in their retirement account if they want to live, well, the way everybody hopes they could live after they retire. Do some traveling, do things that you didn't have time for, weren't really allowed to do when you were younger, when you were working. So that's definitely not $1 million. She's got a way to go. So hopefully as she works and she starts to make more money, she'll put more of that money into the annuity and start making more money. All right, so that was another large chunk of what we had to do today. We learned about the future value of annuities. And we have one last piece, which I really hope that all of you experience someday as home buyers. Not many of us can just put the money out for a home. Most of us have to take out a mortgage. And that's what's happening here. And even if it's just a car loan, you can use this formula to figure out, what should my payments be? So loans and mortgages, talking about present value. The present value, the net amount of money put into annuity, or the amount of money that you have to pay for something. Banks use the present value of an annuity to calculate the monthly payment necessary to amortize a loan over a fixed number of months. And amortize means to reduce or extinguish the debt by money regularly put aside. So figuring out those payments, knowing what's going to happen. As you get to college, and some will have to take out loans to go to college, you have to keep track of that information. How much money did I owe this year? How much money do I owe now that I'm in my second year? What types of loans are they? Am I going to be able to have a grace period where I graduate and I don't have to start paying it back for 6 months? Or do I have to pay it back right away? All of those things are important. In fact, that's something I was just talking over with my daughter who just graduated from the U. Just last night we were talking about her loan payments and what we're going to have to do. We illustrate this reasoning by assuming that a bank lends you a present value of $50,000. at 6%, which actually right now is really high. There are some really low rates out there for purchasing homes. So $50,000 at 6% to purchase a house with the expectation that you will make a mortgage payment each month at the monthly interest rate of, well, 0.06 divided by 12. You can think of that as our I value, which is 0.005. So it says the future value of the investment at 6% compounded monthly for n months is. So they're using the present value and then that interest to figure out how much this would be. The future value of an annuity of R dollars with the loan payments is here. And what they want to do is they want to make sure that the present value of the money they're giving you now equals the future value to pay off that loan in the future. And it says to find R, we would solve the equation. And of course, this one was specific to the information that they had up there with the 50,000 and then the 0.06 divided by 12. So they need those things to be equal. And what we see is, well, in general, this would be the present value times 1 plus I to the n equals R times 1 plus I to the n minus 1 all over I. And that formula looks familiar because that's our future value formula for the annuity. Now, if we were to divide both sides by the quantity 1 plus I over n, then we get a simplified version of this formula. And that's what we see for the present value of an annuity. So the present value, PV, of an annuity consisting of n equal payments of R dollars earning an interest rate of I per period, our payment interval, is. And this is a little bit different because we see that this one now has a negative as an exponent. And that's because, like they said, they went through and divided 1 plus I to the n on both sides. And that made that happen. So I know it says present value of an annuity, but I really want you to think about this in terms of loans and mortgages, because that's what this formula is used for. Figuring out, okay, what do I owe every month? How am I going to make this happen? And R is that payment. That's what we're trying to figure out. So we have Carlos. And Carlos purchases a pickup truck for $18,500. What are the monthly payments for a 4-year loan with a $2,000 down payment if the annual interest rate, the APR, is 2.9%? So the first thing I do is I see Carlos is not going to finance $18,500. He made a $2,000 down payment. So Carlos has to finance $16,500. And that is what we put on the left-hand side for present value. Because that's what he's going to owe when he drives away, is that $16,500. But of course, there's interest that he has to pay on that and all that good stuff. So we want to know what those payments would be. And that's R, the periodic payment. And then we want to go ahead and use the rest of this formula, thinking through, all right, what's I? Well, remember, that's going to be the interest rate per compounding period. So 0.029 divided by, and like most loans for vehicles and for homes, it's going to be monthly. So that's our K value. So 1 minus the quantity 1 plus 0.029 to the 12th to the negative. And then we need the number of compounding periods. So monthly payments, and it says this is a 4-year loan. So that'll be 48. That's our numerator. And that's going to be divided by that I again, which was the 0.029 divided by 12. So again, a lot to keep track of if you wanted to punch it in all at once. Lots of parentheses to keep the calculator doing what it's supposed to do. You know, we have to give it the parentheses to tell it the order of operations. But as I said before, what I'm going to do is punch this in, and basically, oh, come on, Blue, work for me here. I'm going to take 16,500 and divide it by there. I think I've got all my parentheses matching. Nope, I do need this one here to let it know that that's the numerator right there. And that'll give me R. So I'm still going to start all of my punching in over here on the right-hand side. But when I get done with the right-hand side, I'm going to take 16,500 and I'm going to divide it by that answer. So away we go. Make sure got all the numbers sitting in front of me right here. Clear out what we had before. So this one would start at 0.029 divided by 12, innermost parentheses, add the 1, raise that to the negative 48th power, and let's see, we need 1 minus what we just did. So you'll use the second negative key for the answer. Now finally, that's the numerator. So let's divide that by 0.029 divided by 12. All right, so that's everything on the right-hand side. Now I want to take 16,500 and divide it by that answer. And there it is. So $364.49. Now, if you look back at that, you see we did have to do a little bit of rounding for that answer. So in reality, what happens is out of those 48 payments, we'd pay $364.49, or I guess I should say Carlos would pay that, for 47 months. Then the last payment would be slightly less. And that's because we rounded up. So you'd have, a penny every time that you're making one of these monthly payments that would come out of that last payment that you've made. And that's what banks usually do. Your payments are just a little bit bigger for all of the months except for the last one. And then for the last one, they always say you can call in and find out what your last payment would be, so that in the case of a vehicle, you can get the title to that vehicle released. Because titles are held with the loan information on them. And that's because, well, the bank technically owns your vehicle until you pay them all their money back. So there it is. Those were the last two chunks of our learning objective that we had to learn about. And they are just formulas, but you can see they're complicated formulas. So we have to be careful when we're punching these in. There are not a lot of intermediate steps that we can show for this. I mean, we just have to be super careful when we're punching it in, unless, like I said, if this I value works out to be something perfect and nice, well, then you can stop along the way and write down a number or two. But most of these, we're just going to be punching them in very carefully. In fact, if it were on a test, I'd be punching it in twice to make sure that everything has been punched in correctly. And we need a little bit of practice at that, which would be the day 2 assignment. So that was the last of new material that we're going to learn this semester. Again, no cumulative final exam. We're taking the non-calculator portion of the Chapter 3 test on Friday, and then we're going to take the calculator and formulas portion of the test on the 28th, which is the last day of the semester.
Is there going to be a review assignment tomorrow?
Yes, you're going to work on the review assignment tomorrow, exactly. So tomorrow I do want everybody to quick check in, and that way I can answer any questions anybody has. But yes, definitely just the non-calculator portion. Don't get carried away. The non-calculator review, it's separate from the calculator and note, formula portion of the test. But there it is. And yeah, some people are signing off. So have a great day, everybody. But you're welcome to stay on and work and ask questions up until 8:55 if you need to.
Miss Cedarholm,
Yes.
I have to take a test for second hour in school on Friday.
Okay.
Like a college credit test, whatever. Is there